All right, so we've talked a lot about similarity in triangles and polygons and figures. We're going to go over today just some more problems that have to do with similarity. So this first theorem says it's called the triangle proportionality theorem. And what it says, if a line parallel to one side of the triangle intersects the other two sides, then it divides the two sides proportionally. Right? So if you look over at this triangle, like these two lines are parallel. That is, the third side is parallel. This side intersects a triangle and is also parallel to that line. It splits it up. So if I compare RT right there, to TQ right there, it's going to have the same ratio as RU to US. So if you want to like color code those, like we're going from that one to that one, it's going to have the same ratio as that one to that one, going that direction. Okay, as long as those two lines are parallel to each other. Hey, the word converse in math means basically you're going backwards. So if you read this theorem, it says, if a line is parallel to one side of the triangle and intersects the other two sides, then it divides the two sides proportionally. Well, converse, if you notice the if and the then part are switched. This one says, if a line divides the two sides of the triangle proportionally, so notice that part up here is the then part, okay, then it is parallel to the third side. So that was the if part. So with converse theorems, it just takes the if and the then and switches places. Now the converse is not always true, but in this case it is true. Okay, and if you notice in the book there, they have a proof for. If you want to look in the book, you can see the proof that goes along with those. Okay, so what it's saying down here is if you can show that that side, like RT and TQ, has the same ratio as RU and US, that's enough to prove that they are parallel to each other. So it goes both directions. They're parallel. The sides are proportional. Those segments formed are proportional. If the segments are proportional, then they're also that it proves that the two lines are parallel to each other. Okay, so let's try this problem right here. It says in the diagram QS is parallel to UT, right? It's got it marked here with those red marks, right? So they're parallel to each other. RS is 4, which is labeled on the figure. ST is 6. QU is 9. What is the length of RQ? So RQ is this segment right here, right? That's what we're trying to find. Well, since the lines are parallel, we can set up a proportion. So if I compare this side, RS, which is 4, to this segment, ST, which is 6, it has to have the same ratio. They have to be proportional to this side. So the RQ and the QU. So RQ is what we're trying to find. It's X, and QU is 9. But that's it. Once we have that, we just solve that proportion, which we've already done. So if I cross multiply, I end up with 6X equals 36 divided by 6. So X is equal to 6. Here's another example. Okay, so again, it's marked on here that these two lines are parallel. I'm trying to find YZ, that's this side down here, so we can set up our proportions. So if I compare 44 to 35, that has the same ratio as 36 to X. Now notice you have to go in the same order. So if I'm going 44 to 35, then it has to be 36 to X. You have to make sure you keep that order the same. Okay, we just cross multiply, go 44 times X equals 36 times 35. You'd multiply those together, divide, and you got your answer. All right. So here we got this application problem. It says on the shoe rack, BA is equal to 33. That's that segment right there, right? So it's 33. CB is equal to 27. That segment is equal to 27. CD is equal to 44. That's that segment right there, right? And DE is equal to 25. So the question is, explain why the shelf is not parallel to the floor. You can kind of look at it and see it, but we can actually prove it. What I would do is I'd set up my ratio. If they are parallel, then 27 and 33 have to form the same ratio as the 44 to the 25. I mean, you could simplify those, but we can already see 27 is smaller than 33, 44 is bigger than 25. They cannot form the same ratio, so they can definitely not be equal. Which, remember, the converse theorem says if those segments are not proportional, then the sides are not parallel. You guys try this one. Pause the video, give this one a try, then come back and I'll show you the answer. This is using the converse theorem, right? So I know the length of the segments and I want to find out if they're parallel. So if I set up the ratio, I'm going to go 50 to 90. And the question is that equal to 40 to 72? If it is, then the sides have to be parallel. If not, then they're not. So 50 over 90 is pretty easy. It reduces down to be 5/9. So let's reduce 40 over 72. I think you can divide them both by 8. And you also get 5/9. So they are equal. What that means, we've just proved that side SP and RQ are parallel to each other. So it works both ways. If the lengths are parallel, if the segments are parallel, then the segments formed will be proportional. If they're proportional, it proves that the lines are parallel also. Okay, here's our next theorem. This is called 3 parallel lines theorem, although it could be more than 3. See if this makes sense. It says if 3 parallel lines intersect true transversals, then they divide the transversal proportionally. Okay, so I've got these 3 parallel lines. All right, there's my first one, line S, and line T, and they go through line L and line M. So what it's saying is if I take these segments formed, UW, and compare it to WY, and then VX to XZ, those will be proportional to each other, as long as those lines are parallel to each other. And again, there's an example of the proof if you want to look at the proof and see that. Okay, so let's get this problem right here. It says in diagram, angle 1, angle 2, and angle 3 are all congruent. GF equals 120, which is labeled on there. DE equals 150. CD equals 300. Find the distance of HF. So we're trying to find HF, which is actually this entire thing all the way along there. Well, I already know this part's 120, so I'm just going to label this part right here as being X. And then because the lines, it tells us the streets are parallel to each other, right? So all these streets are parallel to each other. So if I compare the line segments, if I go 150 right there to 300, that has to equal 120 to X. Now you could actually cross multiply and solve, but really I'm just doubling, right? 150 to 300 is doubled. So if I double 120, X would have to be 240. You could also cross multiply there if you wanted to. Well, that means this segment right here is 240, but it wants me to find HF, which is the entire segment. So if I add those together, the answer is 360 yards. It'd be the answer to the whole thing. Okay, here's your next one. It's called the triangle angle bisector theorem. You guys have seen angle bisectors before, right? So this is an angle bisector. What that means is it simply cuts that angle C in half. So both of those are congruent. If you have an angle bisector, what it says, if a ray bisects an angle of a triangle, that's the F part, then it divides the opposite side into segments whose lengths are proportional to the lengths of the two sides. Okay, so what it says is if I compare AD to DB, it will be the same as CA to CB. So the ones that go together, right? That one to that one will give you the same thing as that one to that one. And again, there's a proof in the book if you want to look at that. All right, so here's some examples of that. So first of all, notice it tells us that QPR, which is that angle, is congruent to RPS, which is that angle. Well, what that means is that PR is the angle bisector, so it cuts it in half. It says use the side lengths to find the length of RS. So we're trying to find this piece right here. Now, kind of tricky is it does not tell me QR. It gives me the whole thing. But if I know RS is X and QR is 15, sorry, and the whole QS, the whole thing is 15, that segment right there would just be 15 minus x. Okay, so what that theorem says is if I take this segment to this segment, so 15 minus x, let me switch that pen up, 15 minus x compared to x has to equal 7 compared to 13. So I'm going to go 13 times 15 minus x equals 7 times x, right? Just cross multiplying. We'll see 13 times 15. Oh, let's see. 10 times 15 would be 150. 3 times 15 is 45. So I believe it's 195. I'm doing this without a calculator. So if you catch a mistake there, feel free to fix it on your end. Add the 13x over 195 equals what? 20x divided by 20. Okay, and that's going to come out to be a decimal. You see 20 goes into 200 10 times, right? So that means what it goes into it 9 times would be 180, so it'd be 9 and 15 20ths, which is 9 and what, 3/4. So 9 and 3/4 or 9.75. Again, you can use a calculator if you want to double check that. But the main idea is that the important part is setting up the proportion here, right? And again, it just goes, I'll do it different colors. It goes QR, which was the 15 minus x, to RS. Has to be the same as, I'll do a different color here, PQ to PS, is 7 to 13. All right, let's try, let me just do a couple of these really quick. I want you guys to try 3. So pause the video, try 3, then I'll show you what I got for the answer. Okay, it wants me to find that little piece right there, which is x. And if we know that these angles are congruent, that means these lines have to be parallel. So they're all parallel to each other. Well, that means I can set up my proportion, right? I can go 16 over 40 equals x over 30. This went 16 over 40 equals x over 30. And I can cross multiply and solve that from there. No, I don't care. I'm not going to actually go take the time to cross multiply and solve. You guys could do that. But that should have been the proportion that you set up when you went through and solved that. Okay, let's try one down below. I'm going to give you another one to try. So again, pause the video. This one's got a square root in it. That's kind of fun. Go ahead and give that one a try. All right, so hopefully you're done trying that. Again, this is an angle bisector, right? Those two angles are equal. So that means if I compare that to that, 4 to 4, that has to equal that to that. So that'd be 4 square root of 2 over y. Now you could cross multiply and solve, but 4 to 4 is 1. So this side has to come out to be 1 also. That means y has to equal 4 square roots of 2. All right, there's one last thing you have to know, and that is a problem like this. It says, this is one I've actually seen on the ACT before. I was almost not going to include it. Not a huge deal, but I've seen it on an ACT problem, so I thought I'd show it to you. It says, find the coordinates of P along the directed line segment AB. Directed means it goes in a certain direction. So AB, you're starting at A, and you're going to B. You're going that way. So the ratio of A to P to B is 3 to 2. So somewhere along this line, you've got to put a point P. I don't know where it's at, but you got to put a point P where the ratio comes out to be 3 to 2 when you compare them. So here's how we're going to do this, is we're going to just first of all, if I have the ratio from 3 to 2, what that means is I'm going to divide the line into 5 parts. Okay? Because I'm going to go 3 parts and then 2 more parts. Okay, 5 parts total. So I'm going to divide the line into 5 parts. So I'm going to count, I'm going to take how far I go up, which is 1, 2, 3, 4, 5, 6. You go up 6. And we go over 1, 2, 3. And you go over 3, right? There's my slope is 6 over 3. Up 6 over 3. Well, I want to take that, and I want my ratio from A to P to be 3 to 2. That means I want it to be 3/5 of the way up. So what I'm going to do is I'm going to take that slope. I'm going to times the top number 6 by 3/5 and the bottom number 3 by 3/5. So that times a 6 by 3/5, I get 18 fifths. 5 goes into that, 3 times. So I'm going to go up 3, and there'd be 3 left over. So 3 3/5, or 3.6 up. Okay, and then I'm going to times the 3 by 3/5, that'd be 9 fifths. Okay, that'd be 1 4/5, which is 1.8. So I'm going to go 1.8 over. So I've got to start at A, and I've got to go up 3.6, and over 1.8. So let's think of where that point P would be. Well, my x-coordinate is 3, and I have to go over 1.8. That's going to put me at 4.8. My y-coordinate is 2, and I have to go up 3.6. So I add those together, and I get 5.6. Let's see if that looks like it fits. It forms a ratio of 3 to 2. So I'm going to go to 4.8. There's 5, 6. So 4.8, somewhere in there. And then 5.6. Okay, the question is, does that look like a ratio of 3 to 2? I think that looks pretty good. Think of it as 5 equal parts. 1, 2, 3, 4, 5. Right, we've got a ratio of 3 to 2 right there. So just kind of review what I did there. We'll do another example to end it. But what I did is I took my ratio, which was, I thought, the ratio is 3 to 2. So it's really, you're going 3/5 of the whole line. And then I just took my slope. I took the rise and the run. I times them both by 3/5. And that told me how far to go up and how far to go over from that original point from point A. And that allowed me to find out where those coordinates were. Let's try this one. Let's just do one of it. In fact, let me have you guys try it. I want you to try number 7. So pause the video. You can do this by hand. You don't really need graph paper. But give that a try and see if you can come up with it. So point A is at 1, 3. That would be right there. Point B is at 8, 4, which would be right there. And it wants me to come up with a ratio of, it wants P to be at a ratio of 4 to 1. So that really means I need to go 4/5 of the way up and 4/5 of the way over. So count your up and over. It goes up 1, and it goes over, I think, 7. So my slope, right, I'm going up 1 and over 7. Well, just times both of those numbers by 4/5. So times that by 4/5 and times that by 4/5. Okay, so that means I have to go up 4/5, right, 1 times 4/5. And I have to go over, or 0.8 if you want to write it as a decimal. And I have to go over, I'll see 7 times 4/5 is 28 fifths. So that's 5 3/5, or 5.6. So I have to go over 5.6. So if my coordinate A is at 1, 3, my coordinate P, I have to go, the x is at 1, and I have to go over 5.6. So it'd be at 6.6. And then the y-coordinate was at 3, and I have to go up 0.8. So I'm going to be at 3.8. So let's see if that looks like it fits. So I'm going to go over to 6.6 and up to 3.8, somewhere in there. Okay. Whoops, my line wasn't very straight there. But if you picture that, right, we're going over 1, 2, 3, 4, and then I have 1, right? I have that 4 to 1 ratio. So that looks good. So again, all we do, you find in the slope, and then find the ratio of how far you're going over to the total. So even though it was 4 to 1, that really means you're going 4/5 of the way over on the line. Times both your top and the bottom by the 4/5. That will tell you how far to go up and how far to go over from the original point. You always start at the original point A. So I went over 0.8 from there and up 5.6 from there. Or sorry, over 5.6 and up 0.8. So I can take those, add the over to the x and the up to the y, and you end up with a coordinate point there. Okay, hopefully that was helpful to you. I think that was everything from 8.6.